I'm a software developer, a mathematician, and in the last years, I've been working on the projects at Tauchain and Agoras. Imagine something that looks exactly like Facebook. Groups, likes, posts, comments. Just instead of writing in English, they write in, call it controlled English. They write it in very simple English that computers can digest. And from here, we get all the additional features that can come because the computer can understand. For example, to show me who agrees with me and who disagrees with me and about what. Or to summarize the whole discussion into a map of opinions, to take 1 million people and to extract from them, I don't know, 100, 1,000 opinions. It will not be 1 million opinions. So how this is how it is going to look like a social network where people write in language that machines can understand. Tau is a technology that comes to achieve a very certain goal that sounds quite boring. It comes to achieve the goal of how people can develop a software collaboratively, such that the software that they collaboratively develop is the very software that let them do so. In other words, Tau does nothing except what its users want it to do. Now, how to achieve this goal? It turns out that in order to achieve this goal, we have to solve important social issues. And by that, we can solve even further social issues. And by social issues, I refer to the ability to take a collaborative decision in a way that is actually effective. And the economy is also a very special part of society. The ability to trade knowledge and more, I will explain more later in a more structured way. So in order to have a software that is controlled by its users, the users, first step, they have to say what they want. How are they going to say what they want? As we shall explain later, it turns out that the ways that we can support that can possibly be supported are not too few and not too many. How the users are going to express themselves, we can call this question as the question of language, which language the users are going to use. And again, we will see that it cannot be too many languages and it cannot be too few languages. And the next step, after the users express themselves, now they have to somehow know what other users think. It can easily be done in small groups, but how can they be aware of what other users think in large groups? Right now, the only way that we know to take a decision in large groups is by one, voting, and two, by using a hierarchical structure, a centralized hierarchical structure. But when we vote on something on large scale, say like in a country, all our opinions sum down to few numbers. All the vast information, all the things that we have to say disappear, because there is no capacity to propagate and process all this information. So we fall back to voting. And who propose what to vote over? We do it by hierarchical and centralized structure. Another point, another issue to solve is after we got collaborative decision by whatever means, we need the software to follow those agreements. So we will need to be able for the software to understand what its users agreed on and to act accordingly. So for that, we have to come up with a system that allows efficient propagation of knowledge in a way that machines can manipulate this knowledge. Suppose you have 1 million people, each saying their opinion about anything. You will not find 1 million opinions there. If you have 3 people, you might have 3 opinions. But with 1 million people, you will find many repeating opinions. Can we see a map telling us which opinions those million people expressed and which each subscribe to? And by that, really extract all the information that people actually gave. Well, right now, there isn't any technology to do so without help from the users. Of course, it would be great if computers could just read everything we wrote on the internet and know our opinion about anything, and then build the opinion map and then see where we agree and where we disagree. But as we know and feel very well and very painfully, the computers don't understand us. For this to happen, for a real large-scale collaborative effort to happen, we will need to take a step towards machines and speak in languages that they can understand. It doesn't have to be programming languages. Programming languages are mainly about instructing the machines which steps to make. But this is not what we want to explain. We only want to explain our opinion to the machine. And by that, it can detect what we indeed agree on and help the process of creation and convergence and propagation of knowledge to be efficient in large scale. So this is in short, what Tau is about. This is the technology of Tau. By that, we take it one step further to knowledge economy, and this is what Agoras is about. Right now, there is no way to trade knowledge directly. We trade knowledge only by indirect means. For example, I trust someone is an expert in some field, and therefore I'm willing to pay them in order to get their opinion, but they don't sell me the very piece of knowledge that they give me. They sell me maybe their time or something like this. But we are about to create a pure knowledge to cash transaction. Once we will be able to put our knowledge in a formalized way, in a way that the machine can use this knowledge without our intervention and can also serve this knowledge to other people without our intervention and answer all questions about the subject by means of logical solvers, again, without human intervention. Once such knowledge is formalized by someone, they can also monetize it. Imagine a university formalizes a large body of knowledge about, I don't know, philosophy or law or anything. And you would like this body of knowledge to automatically participate in your discussion. Indeed, on Tau will be able to participate in discussions on behalf of you automatically, of course, if you give it permission to, because it already knows your opinion. And for such participation in a discussion, automatic participation, they can charge a fee. And we have a knowledge economy. When the knowledge is monetized directly, fully automatically. Moreover, let's think about contracts. Contracts contain certain conditions that are typically very formal. They are written in very formal language. And once we can write very complex contract that the machines can understand their consequences, that we can ask any question we like about the contract, and we are guaranteed to get an answer. By that, we can offer new kinds of markets, like computational market, and also an advanced form of derivatives market. And this will also be part of Agoras um, as, uh, as part of having the Tau core that allow us to manipulate knowledge directly. Yet another important part of Agoras, and maybe the last point for this answer, to not make it too long, is that because it is powered by Tau, it will certainly be controlled by its users. The one who will determine the rules of the Agorans cryptocurrency and the whole ecosystem will be known by the users themselves. At the moment, the users, there will be consensus about changing the protocol or changing any aspect of the system whatsoever, even rewrite the whole code. The system will simply change itself. By this, we get a decentralized network that is decentralized also in its development. So far, all decentralized networks have a centralized development team. But on Tau and Agoras, there is no distinguishment between the users and the development team. The users fully own the network to the full extent. Well, I mentioned before, and I didn't explain, that the first step in the sequence is for users to express their opinion. That's the first step. Now, how are they going to express their opinion? Well, one immediate thought that people try to come up with is to offer a language. And they say, okay, all the users will use this specific language. And that's what they will express their opinion. But we postulate that such thing can never work, because there is no one language that is adequate for all users. Even English is not really a language. It is a template of many languages. Same words mean different things in different contexts. When we speak about, I don't know, computers, we use a sub-language of a language which is a sub-language of the English template. So the languages cannot be too few. Moreover, the languages need to evolve with time. We cannot come up with a language and say, oh, will be good enough forever. That's yet another reason to not have one universal fixed language in the system. So by this rationale, we would like to allow many languages on the system to coexist and evolve with time. Now, how can that be if one user writes in one language and the other user writes in another language? How the system is going to match their opinion? Well, in order to use a language over the system, that language will have to be defined. To define a language is done by means of how this language translates to another already defined language. If I have an engine that can take a document in one language, which we don't understand, and to translate it to another language that we do understand, by that we made a support for the first language. And this is what we call the Internet of Languages. And a network of translators that allow us to translate back and forth between all languages that defined over the system, that users can define at any point of time. This all regarding the part of not having too few languages. Now it turns out that we can also not have too much languages. Because it turns out that there are very serious mathematical restrictions, theoretical restrictions of what can we do. We mentioned that we want to build the opinion map from what users say, and it turns out that for many kinds of languages and logics, this task is impossible, even to calculate the agreement between two users. If they use rich enough logic, this will be impossible. So we need to restrict the logics and the languages that we can use. And this is done by our three postulates of the laws of laws. And we say that the law has to be one decidable, namely to get an answer to the question, is something legal? We simply ask it to not take infinite time. That's very modest request. Second, we want the law to be able to refer to itself, namely recursion. And third, we would like to be able to delete old laws and legislate new contradicting laws. Those three requirements pin down a very specific family of logics. And the Internet of Languages will indeed mainly be intended to support those kinds of logics that we can then manipulate and reach a large-scale collaborative decision process making. Prolog, Datalog, TML come from a family of languages called logic programming languages. They aim to be at least partially declarative. Declarative means that you say the what and you don't say the how. Prolog is not fully declarative, but Datalog is fully declarative as well as TML. And aside from being logical languages, Datalog, TML, and Prolog in this order have some unique property. The unique property of the ability to self-define. Prolog is able to self-define just like any Turing-complete language. Prolog is Turing-complete, logical programming language that can indeed self-define itself. Datalog is not Turing-complete language. It is so-called polynomial time complete. And it can also redefine itself, and same from TML, which is so-called p-space complete. It turns out that aside of these three, Turing complete, p-time complete, and p-space complete, there isn't really any other choice, any choice of logic that satisfy the requirements from the language of law. So Datalog doesn't satisfy the third requirement. Datalog doesn't allow us to delete old laws and legislate new laws. Datalog is so-called monotonic logic. Monotonic logic means that everything that was true in the past is still true now. But we, of course, require non-monotonic logic because reality changes. And Prolog violates the first rule of the laws of laws, which is decidability. You will not be able to get an answer to any question you ask in finite time. Only TML, the sweet spot in the middle, satisfy those three requirements. In small groups, with 3, 4, 5 people, we can have a conversation just fine, and we can get a decision just fine. We don't need to vote. Just listen to each other, say what we have to say, and we don't need to vote. We already know and see who says what. Tao is about taking what happens in small groups and try to make it work in large groups. Just like in small groups, we just say what we have to say, and that's it, that's enough. Same on Tao, on large groups. We will just have to say what we have to say, and this will be enough. From here, the machine will process our knowledge and build the opinion map and see where we agree and disagree. So in short, it is all about taking what's happening successfully in small groups, and with the use of logic-based artificial intelligence take it to large groups. As we spoke before, we refer to knowledge economy, the ability to have a pure knowledge to cash transaction, the ability to monetize knowledge directly. Right now, the knowledge economy is so inefficient. The ability to manufacture new knowledge, to ship new knowledge, to price knowledge. Those are all things that are currently very, very vague and have no accurate and efficient economical setting. This all can be solved in the world of Tau, where the knowledge is fully accessible to the machine and can then even create new knowledge and let other users use your knowledge without even your intervention, and to price the knowledge and to charge for usage. So we take to, if the internet is about connecting the people, connecting machines, then Tao is about connecting them meaningfully. Upon all this, all its economical implications, as we saw right now. The dream of using logical solvers for various reasons, including for the ability to convert requirements from software written in logic into actual code, is very old. And the main bottleneck is performance. Now we have, of course, much faster computers, but it is still a great challenge to write a fast logical solver. And indeed, this is what I've been focused on in the last few years. And to a large extent, this goal was achieved thanks to incorporating the technology of binary decision diagrams and identifying their relevance to the specific logic that TML subscribes to, which is called PFP, partial fixed point logic. So that was indeed a huge challenge. And the next huge challenge will be to make the system usable. We can make a system that people will write in TML and will be able to discuss in TML and change the code. But if it will not be usable, then it will be useless. Eventually, we will need real people to use this without being experts in logic. And this will be our next big challenge, how to make this system really usable. Blockchain is about timestamp. The field of cryptography came up with very fancy and useful tools, hashing, signing. They allow us to secure certain things, but they don't allow us to, until Satoshi came, until the blockchain was invented, they didn't allow us to tell which event came first without the need of trusting someone to tell us who came first and who can also cheat. It is not always important to know what came first. You will see many blockchain-powered projects out there could solve their problem using traditional cryptographic means, and they simply don't need decentralized timestamp, and there is no need for a blockchain. On Tau also, if I say I like ice cream, it is really not so important at which point of time I say that. I'm not going to broadcast the transaction to a blockchain, to mine it, and to pay transaction fee. There's no need. Sometimes we want to timestamp something important. An example of something vital for Tau to timestamp is the code of Tau itself. We said that the users can change the Tau code. So at which point of time we have the current Tau code, we can think of it as the current block. And then we have many opinions of what should be the next code, namely the next block. And then we need to reach some consensus of what should be the next block, namely the next code. And we all agree on it. We don't want to have, we cannot allow to have users on the network not agreeing on what is the current code. For this, we indeed need blockchain. And by that, users will be able to timestamp any other data on this blockchain, whatever they want to timestamp, not only the code of the Tau itself. To find more, you can see on other website, IDNI.org. IDNI stands for Intelligent Decentralized Networks Initiatives. Our main community is on a Telegram group. You can see a link on the website indeed. And please join our community. There is so much to think and to say about these social issues that we discussed, and we'll be very happy to hear your take on those things.